man, such a long pause, it's so hard to record a new video. But I am back with a new video. 2 languages, same web server, same features, but one of them makes me feel powerful and another makes me feel fast. So Rust versus Golang. Let's see which of them actually enjoyable to develop. The idea is a tiny API for 2 different entities, users and tasks. JSON in, JSON out, just enough to fill the language. And for storing the entities, I'm going to use the Postgres database. They're pretty much standard. For handling HTTP requests in Rust, I'm going to use Axum, which is pretty stable and popular. And in Golang, for HTTP requests, I'm going to use Gin, also very famous and popular framework. For handling the database requests and connection, I'm going to use in Rust Diesel ORM, and in Golang, I'm going to use GORM. So let's see which of them performs the best. For that matter, I'm going to implement in total 6 endpoints, 3 for users and 3 for tasks. For users, the first one, post users to create a user, get users to get a user, and the last one to get users ID tasks. This one returns tasks of the user. And for tasks APIs, I need post tasks to create a task and get task to get a task. And the last one, put tasks by ID assign. I needed to assign task to a user. Let's flip the coin to decide the first language. Go. It's Rust. Initialize the Rust project. And we created the project. Oh, here we go. Our project in Rust in ZIDE. Let's specify our dependencies. We need Axum, we need Tokyo with the full features to support our asynchronous application. Axum, we need to handling HTTP requests. We need Diesel for handling ORM and connection with the database. Also, we need a connection pool. There's a connection pool. We need UID, Chrono support. We need Serde to serialize, deserialize data, Serde JSON, because we need to do that in JSON. UID goes with the version 7 to have it in order. So basically, this is time-based UIDs, and it's really nice to have. Also, we need the Chrono, also with the features Serde. In Rust, those features, you can control what you actually need. Then we need to open the console, and now let's set up first of all the database URL. We need it for Diesel, then we need cargo install Diesel CLI, and we need to install Diesel CLI, no default features with only one features Postgres. Now we're almost ready, so we need to use the Diesel setup. And Diesel setup creates a Diesel toml file and migration folder. Diesel setup contains the scheme and some directories to migration folder. Then we need a Diesel generate init. Diesel created 2 files for us inside of the migration folder. Here you can see the up. Let's create 2 tables, users and tasks. And then down, we have to specify the drop table tasks and users. Oh, and I need to save all the files. So everything is saved now. We have our migration up and down. Now let's hide the migration. We need here to import a bunch of stuff, and we need to create user and a couple of annotations. First of all, derive is very famous thing in Rust, but this entity must be queryable, selectable, serializable, also support debug for errors and clone. And in Diesel, we set up the table name users and check for the backend we want to use the Postgres. This is a read entity. Additionally, we need write entity. For that, we call it new user. 2 fields will be automatically generated. And for this field, we need also a derived. It should be insertable, table name users, same table name. Exactly the same for the task, but a different table name, and also insertable. That's all we need for models. Now we can use the Diesel migration and run the migration, and it generates the scheme file. Here's our new generated file. It's generated automatically by Diesel CLI. Here's maps our model entity, same for the users and same for tasks. Also, it's generate additional parameters like Diesel joinable, allow table to appear in the same query. That's good to have because they are related to each other. Now let's create a database file. We need 2 imports. And also we can fix the spell color just by importing them inside of the main models, scheme, database. Save it. Let's continue with our database file. Here we need to add a couple of things. One of them, I'm going to map this very long type to the small name. It's basically, call this DB pool. Establish connection with the database. Here I am creating a manager and using my database URL, which I provide to this endpoint. Database URL, I will provide function parameter and create a pool based on my manager. Now let's continue with our main. Here we need to read database URL from env parameters. We need to import a couple of parameters. In Rust they call it use. Then I need to create a pool. Our database is configured. Now let's continue with the HTTP handlers. Let's create a file. First of all, we need to import a couple of things, and the very juicy is here. We need to import crate with our DB pool and models related to the write models and read models, and also two schemes. Then let's define the create user. It will return into response. For two parameters, we need to create one additional entity, create user request, and it should be only deserializable because we only parsing it from the user. And what I like in Axum, you can just provide the state in JSON. Here you have your simple method to handling HTTP request, and it parses automatically the JSON with this type, create user request. Nice. In main, we need to configure our router. We have our simpler router, but we can't run Axum because it's asynchronous. Our function must be async, and we have to use annotation from Tokyo. So we have our socket address. Then we need to create TCP listener, and this one is asynchronous because we are using a Tokyo. This is a synchronous library for Rust. And then we're providing this to Axum. We Axum serve our listener with this route, await, and run it. That's it, and also comma here. Now our basic server is ready. Let's run it.
The cat came by to have some snacks. Look at this boy. He's nice. I need to get some treats.
So it's running, my congratulations. But now let's cancel it and let's implement our first handler to create a user. Here we need, first of all, inside of the create user, we need to create our new user writable entity. We need to get a connection from our connection pool, and then we need to insert this entity inside of our table, verify the error in end. So how it works? Here we're getting a connection, then we use the diesel to insert users table, then provide the values. We can insert the batch, and for return we are waiting the user as returning and get results, and we're running diesel on our connection from connection pool. Then we're handling the result with match. Let's run it. So and now we can run our first request and run it, and here are the first user we created. But I'm almost sure you missed one small thing. Let's look closer to this create user. Everything works fine and we don't have any warnings from the compiler, at least related to this issue. But the issue is diesel. Diesel by default is blocking requests into the database. So this one will block the whole thread the Axum is running on. And Axum is a synchronous thing. And if one of the requests waits for database response, then Axum can handle other things without blocking the whole thread. But the diesel blocking the whole thread here, and we need to handle it properly. We can use async pool, but it doesn't work very well with diesel. We can handle it with Tokyo. To handle it with Tokyo, we remove both of them. Instead of the connection pool, we need to use the Tokyo to spawn a task, and this task will send this very fatty request to the specific thread without blocking the Axum, which is really nice, and Axum can handle much more requests. Here we're doing all of the separations, like getting a connection and inserting using a diesel into the database. The first complication. Maybe if you don't know, luxury mechanical watchmakers really like to add complications into their watches. They call them like moonlight calendar or chronograph or something like that. It's a complication, and we are much simpler like that, and not luxury for sure. I'm going to add authentication to implement a middleware, and in the middleware I'm going to read a header. Let's name it Xcode. And if its value is correct, we will continue. If it's not, it's 401 unauthorized. Let's implement the complication and create a file. then implement the middleware. Let's read our Xcode env variable. Then let's read the header and let's match the header. Basically, we're matching if the header is present. So if it's some, checking if the value of this header equals, here we're parsing it from string, header value from string, unwrap. And if it's not present, that's empty string. And if everything is fine, we allow the next handler handling this job. That's our auth middleware. Here in main, let's import additional parameter, because we have this package mod middleware, we have here Axum middleware, and I want to run it on top of everything. So layer, in our router we just added this layer. Now let's create a noise, run it, and now it's 401 unauthorized, and 1 2 3 4 it's incorrect. Let's try it out, run it, it's still 401, it's here, and here we go, we created noise. So our authentication and complication works fine. So here I created more handlers, and in Rust with the Axum you can chain them, and you can see this chaining here. We have post handler, then we're chaining the get handler on the same road. Here we're reading a pass variable. Now we have the full application that worked. Let's move on and see how it looks like in the Golang. We need to create a directory. So let's make, then let's go inside, and here. And now we initialized the God project, the Golang project. And in Golang, it's completely blank canvas. Let's create a couple of folders. And in Golang, let's get started with the models, the package models, a couple of imports, and user and task. I want automatically create ID. For that, I'm going to use the hook before create for user and before create for task. Here I verify if its ID is empty, I will create a new ID with the version 7. And let's create a database. I will use the lazy thing. I'll create a variable database. In normal application, you have to use dependency injection or var or something like that. But for this case, it's more than enough. Let's create a database. Then about the error handling, we need to specify the error. We need to open the GORM connection using our DSN with the empty config. Then we need to handle the error. Then I'm going to run a migration like this with our models. It's automatic migration with user and task. Don't use it in production. And again, I have to handle the error. If everything good, let's print the database connection and migration migrated successfully. That's what I want. Now let's create a main Go in a root directory. The package is main. I want to import our user tasks Go database, and we need a function main. In function main, we can initialize our database. To fix these errors, you can easily run go mod tidy, and it downloads all the packages we need. I need to fix this one. It should be user tasks Go models. Now we can initialize the handlers. Package handlers. We need to import a couple of packages, and we need a package Gin. Simple endpoint, it should be create user. That's it. Let's read the user from endpoint. Basically, we're reading a body from the Gin context and writing this body inside of this user. And also we need to handle the error. Then I use the database and update it here to create a user. Then I need to handle the error one more time. And if everything is good, just return JSON status OK new user. This is simple user creation. The second complication. And for second complication, it should be a little bit more complex. I'm going to add a pagination based on a cursor. How it works. We have the UID version 7. So they are in a chronological order, and we can use IDs to iterate and paginate really fast. Next one is get users, and for that matter, I'm going to implement the pagination. Inside of the users, I'm going to implement the pagination. That's implement the constant equals 10, read cursor. We're going to read our users inside of this variable, order by ID, and we want to get a page +1 to have the next cursor. Basically, we need the next ID. If the cursor is not empty, we query where the ID greater or equal to this cursor. Then we simply find these users. They will be written in this variable. Of course, the error verification. Then we need to get the next cursor. If length of users greater than limit, then next cursor equals the ID of the last user inside of this users array. Then I need to trim users to return the proper amount of users. And then we are ready to return the data and next cursor in JSON. Let's configure this in main. So it should be the Gin. Save it. Here we go. We can do that one more time. We get go mod tidy to download the Gin. This is our router, and we can use our handlers. If I click save, it automatically imports the handlers. So I want to handle users, create user, and let's get the users. So that's it. And in database, we're importing the database URL. I need to do the same thing like in Rust, import. And here we need to run our server. We need to run it like this. And now we can run our Golang server. Now we can create a user. So the response is perfect. Let's create John, run it. So creation works perfectly. Let's get some users. Here we go. And the next cursor is empty. I created more than 10 users, and now we can click get users, have this list, and our next cursor. Now let's provide the next cursor. Here we go, we have 11 people. So how to solve this complication in Rust? Let's do that. So first of all, we need to set up a limit, the same like we did in the Golang. So limit 10. Then let's specify the get users. And how do you remember that? We need to specify the blocking thing. Here we need to move. Inside we need to get a connection, and also the query builder. We need to create a proper query. Here we're reading a cursor from query here. What I like in Axum, we can verify the type of the request with the pagination query. And inside of the pagination query, let's create the pagination query. It should be here. Pagination query, we can read the cursor and it can be option. So we set up our results. It's not ready yet. Here we use our query builder, asking to order users by ID ascending, using the limit +1, and loading the users using this connection. And if it's error, then it's error. And we need to specify what we are returning. And we are returning vector of users and status code because it's present here. Also await, and then let's handle our results. First of all, we need to handle our OK result. If the next cursor is present, we need to get the next ID by limit usize, get ID. Here we need to truncate, it's pretty easy, and return some next ID. And here return the response. And then we need to handle two errors, and we need a paginated response. Should be here, paginated response with the type of T, data vector, and next cursor is optional. So here's our final get users endpoint with the pagination. And we need to build our first complication is a middleware. So let's get it fast. Import some stuff. Let's read expected code. And we need to specify the aus middleware, and this returns a function which accepts a Gin context. Here we need to read provided code and compare our provided code with expected code from here. If they are not equal, the status is unauthorized. Otherwise, let's just handle the next one. Very similar to Rust, isn't it? Now let's apply this to all of the handlers. We can use this middleware, aus middleware. This will be applied to all of the endpoints below. Let's create the env xcode and run it one more time. Now, if I try to create a new user, let's say it Paul, I will get the error unauthorized because we need to provide xcode. Let's try 1, 2, 3, 4. One more. It's still unauthorized because the code is wrong. Now it's correct code, and we created the Paul. Let's copy this, and we need to use this header here. Run it. So the second page is Norris and Paul, and our IDs perfectly ordered because we are using the UID version 7. So it works nice, and the cursor is empty. So I created a couple of other endpoints and also the task and save it. And now we can compare some of them with each other, comparing side by side Rust and Golang, how they look like. And I would say main in Rust and main in Go pretty much similar. Maybe there is a small differences, but except this thing in Rust when you need to create a socket address and TCP listener, everything looks really, really similar. The middleware, if you compare the middleware, you can pause and see for yourself, but in my mind also the middleware looks very similar, maybe except this pattern matching. Maybe there is a way to do that better, but yes, with this pattern matching it looks a bit weird. But if you solve this, maybe it will look similar. But in my mind, it's pretty much the same. But now let's compare the assigned task. I would say there is a pretty much difference and I don't like these differences. One of them, what I don't like is this thing that I need to create a spawning block with Stoker in Rust and it looks a bit ugly. And in Golang, it looks very simplistic, very straightforward, but really ugly error management. And I would say all the time I need to do this if to handle the error and it looks ugly. And working with the diesel, also I think it's not very pleasant experience with generated code. Also diesel much more complicated because you need to call the diesel package update, then you can to feed the connection in the end. But in a Golang, you just call the method and you do what you need and you mapping your request directly to the object. I think it's a much more straightforward in a Golang. Side-by-side comparison. Damn, this one will be really difficult to me because I'm in love with Rust. So I'm going to rate languages from 1 to 5 in 4 categories. The first one, speed of development, how fast I can develop in this language. The second one, confidence, how I'm confident to run this code in production. Third one, fun factor. And the last one, stress, if the language is stressful or not in development. So let's get started with the speed of development. And Golang to me is 5 out of 5. Development is really fast. You can build very complex things quite fast. And in Rust, it's not so fast. And you need to build a lot of things around it. You need to spend the time to configure everything. So to me, it's 3 out of 5. The next one, confidence. Confidence of running the code in production. In Rust, I would say it's 5 out of 5. The compiler helped me a lot. Clippy helps me to fix warnings and also it's verifying the asynchronous code. They're fantastic. In Golang, I'm not so sure. So it's 3 out of 5. I'm not so sure in my code in Golang. So the next one is the fun factor. And I will be honest, Golang is a mediocre language. It's not so fun developing apps in a Golang. Yes, they work pretty good. They small, they compiled language and everything is fine, but it's boring. And also the error handling is awful. It's totally awful. In Rust, development is nice. I would say cargo helps a lot. It's just nice to develop up in Rust. And also, yeah, it's just a pleasant experience, nice syntaxes. Everything is nice in Rust. I would say from fun factor, at least to me. But again, I will rate it 4 out of 5. And in Golang, I will rate it 1 out of 5. Rust is not 5 out of 5 because I think there are other languages that are very fun because of the fun, like Lisp or Elixir or some other languages. They just pure fun of development. So Rust in this matter, 4 out of 5. And the last one, stress. Golang is completely stress-less language. When you're developing in the Golang, it's pretty much breathe. You do not stress at all. And I like it. It's really nice. There are also errors is very helpful. But in Rust, when you fight with the borrow checker, yes, it can be painful. And sometimes it can be really frustrating when you clashing with the borrow checker and it forces you to rewrite a lot of your code because maybe I'm stupid, but it happens to me even after 2-3 years of development, big project in Rust. It still happens to me. Because of that, Golang is 5 out of 5. It's stressless language for sure. It's almost like a Python. And Rust, yes, it's 2 out of 5. It's stressful developing applications in Rust. Let's be honest with everybody. So overall, my opinion about both of these languages. I think the development and programming must be fun. You need to enjoy, especially in the AI era. If you're not doing the business, you have to enjoy programming. And for that matter, if I'm building something fast, when I need to build some services, SaaS platforms, and I need to do a business, Go is a total win. Golang is a total winner in a business perspective. It's really nice to build systems to test them with the clients because it's fast, easy, and stressless. Because in the business, you have plenty of other things to stress about. And if I'm building something I will going to maintain for years, Rust to me feels satisfying. And also in development point of view, if I'm building an app in Rust, I understand that code is pretty much nice and it can last for years. And if I'm programming something to myself, when I want to build, I don't know, something for my Raspberry Pi or small microchips, I can use Rust. Or maybe for some my personal web servers, I can use Rust because I like the language and I can spend more time developing and enjoying, and it's understandable. But for the business, the Golang is total winner. Drop your comments below. Tell me what is your opinion about it. Psst, are you still there? Link to the source code in the description. You can click there. Good luck.